In this video, we're going to talk about compound inequalities. So a compound inequality is really where we're combining two inequalities together. And there's a couple ways we do that. You can see it with these first couple of examples here. One way we can combine them together is with the word or, and another way is with the word and. And those two kind of have different ideas attached to them. So when we see or means that we combine the two together. But when you see the word and means you look just at what they have in common. So I'm going to start by graphing each inequality separately, and then I'm going to look at what it means to think of it as an or an and then take that and draw a new graph of the two of them together based on whether or not we're using an or an and. Okay, so let's start with x is bigger than 3. So if I wanted to graph that, and I'm just going to kind of do a little small inequality graph right next to it. So here's 0, all right, and then here's 3. So x is bigger than 3 means it's all the numbers from 3 to the right. Now, depending on your background, you might have learned to do an open circle when you see a greater than or less than symbol and no equal to bar, an open circle. Or you might have seen it with a parenthesis where they use like a parenthesis. We're going to use the parenthesis approach. So whenever we have a less than or greater than, that's going to use a parenthesis. And then whenever we have the equal to signs underneath, that's going to use a bracket. So it's the equivalent of doing an open circle or a closed circle, but the reason we're going to use parentheses and brackets has to do with interval notation, which we're also going to talk about in this section. Okay, so let's go ahead and do x is less than or equal to -4. So I'm going to draw that on a number line. I'm just going to do it right below. Okay, so here I'll kind of keep 0 in the same place. -4 is on the left now. And if it's less than or equal to -4, that means it's going to be a bracket and it's going to shade to the left this time because we're talking about numbers that are smaller than -4. So what we're looking at then combined together, because we're looking at an or inequality, so is that we're basically putting both of these onto the same graph. So this will end up being from 3 on to infinity and from -4 on to negative infinity, going this way. And that's what the combination of those two together looks like. All right, let's look at an and inequality. So in this one, we're saying that v is less than -5. Okay, so here I'm going to draw a number line. And I kind of see that the next one has a -12. So I'm going to put my 0 over here. All right, here's -5. And if it's less than -5, that means it's going parenthesis to the left. These are all the numbers that are less than -5. And then for v is bigger than or equal to -12. So here's 0 and here's -12. Those would be, first of all, bracket, and they'd be shading to the right because those are all the numbers that are bigger than -12. So since we're looking at and, what we're looking at is what they have in common. And what they have in common are all of the numbers between -12 and -5. So what I'm kind of doing is I'm visually looking at where the two of them kind of overlap each other. And they overlap each other from those points, from -12 up to -5. They share those points in common on the number line. And that's then what I want to draw over here. Okay, so here's 0, 1, 2, 3, 4, 5. There's -5, 6, 7. Oops. Let's fix that one. 6, 7, 8, 9, 10, 11. A little bit bigger here at the end. 12. All right. So I'm going to go from -12 with a bracket, parenthesis at -5, shading. So what I'm doing is I'm looking for where they actually overlap each other. I couldn't have done that on the last one. They don't overlap each other at all, right? So that I couldn't have even looked at an overlap on the last one. But on this one, they do have an area where they have some stuff in common, and that's what ends up being on the final graph. So just so we're clear, these are the final answers, what we have over here. This is the graph of the compound inequality. Now let's look at some more exciting cases. Skip down here. So here, again, we see an and. So we're looking for where they kind of overlap. So bigger than or equal to 9 versus bigger than or equal to 7. Okay, so here's 0, here's 9. And if it's bigger than or equal to, it's going to be a bracket going to the right. For 7, it's going to start a little bit further to the left, and it's also going to be a bracket going to the right. So for this one, where they overlap, they start having things in common from 9 on. From 9 on, that's where they have things in common. So to draw where they have stuff in common would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Not drawing these big enough here. From 9 on, oops, yeah, we'll pretend it's at 9. They have something in common. Pretend that hit exactly at 9. So that would be the answer from 9 on. All right, back to or. So less than or equal to 15 versus bigger than 0. So or means we're combining them together. Okay, so for this one, here's 0 and here's 15. And if it's less than or equal to 15, that would be bracket going to the left. All the numbers less than 15. For 0 here, here's 0. It's bigger than 0. So that's all the numbers parenthesis going to the right. So parenthesis because there's no equal to bar. So if we're combining these two answers together, because they overlap, they end up being the whole number line. It ends up being everything shaded. So the actual answer to this is literally the whole number line shaded. Or another way of saying that would be it's all real numbers. But that's how we would draw it. Be the whole number line shaded. Okay, let's look at this one. Oops. I think this was supposed to be on the next page. I'm gonna go ahead and move it. And I'll be a little bit ghetto and just keep this in the video because you know what, it's fine. All right, here we go. Let's try these two now. A is less than 4. So here we're saying, right, so here's 0, here's 4. Less than 4 would be a parenthesis, and it's shading to the left, smaller than 4. A is bigger than 5. Okay, so that would be 0. Okay, so 5 would be like a little bit over from 4. Parenthesis again, going to the right this time. Now we're looking at and, so we're looking at what they have in common, and they have nothing in common. So if they don't have anything in common, there's literally nothing for me to draw. Oops, why did it do? That was weird. It wasn't even selecting a highlighter. So there's nothing for me to draw. Therefore, that's the answer, a blank number line. There's nothing to draw. And they have no solution, nothing in common. All right. All right, let's look at this last one here. So Z is bigger than or equal to -1. Oops. Okay, so, oops, I'm gonna wanna put -1 to the left. And because I have a positive here, I'm gonna go ahead and actually put it in the center. Okay, so there's 0, here's -1. All right, so it's bracket. And since it's bigger than -1, we're gonna be shading to the right. Oops. And then for Z is bigger than 1, Okay, so here's 0, and then 1's on the right. And it's a parenthesis, and it's shading to the right as well. Okay, so there we go. So since it's an or inequality, that means I'm looking at what they have in, oh, no, I'm sorry, I'm combining the two together. So if I combine these together, basically the first graph, this top graph, is going to kind of contain the bottom graph. So since it already has from 1 on, right, on the right side, the combining them together ends up looking like just the bigger of the two. So from -1 on to the left, that's what the combined graph looks like. So that would be the answer. Okay, now before we get to the next example, I want to come back here and I want to talk about interval notation. So interval notation is a way of writing the answers on the number line in a shorter form. So rather than drawing it, I could indicate, like this last problem, that these are all the numbers from -1 to positive infinity. And the way I write that in interval notation is I say -1, comma, infinity. And then because -1 is included, I put a bracket, but infinity will always use a parenthesis. So parenthesis means it's not included. And since infinity is not a number, it will never have a bracket. We can't ever include infinity. You can't include the number infinity. There is no number infinity. Okay, so that's the idea behind interval notation. So here, let's try it again. I'm going to skip this one, E. We'll come back to that. Okay, so like for D, this one goes from -infinity to positive infinity. So its interval notation would look like -infinity with a parenthesis to positive infinity with a parenthesis. That's the interval notation. I should probably have done that in green. Oh, well, that's fine. Okay, so for this one, it goes from 9 to infinity, bracket at 9, parenthesis at infinity. This one goes from -12, and then it stops at 5. It doesn't go on to infinity. It's got a bracket at -12, parenthesis at 5. It includes -12, but not 5. Okay, so this one has like 2 of them. So this one has -infinity to -4 with a bracket. And then it picks up from 3 to infinity, parentheses around both of those. And then because they're both on the same graph, we use a U to indicate that they're both on the same graph. So these like U's, this capital U means that both of these are contained on the same graph. So I want to come back to part E, which was there was nothing. So the way you represent nothing in interval notation is with a circle with a line through it. That means the empty set. So there's absolutely nothing. The line is empty. Okay, we're going to use interval notation on these next problems. So we'll get to practice that some more. For these, we're going to first solve the inequality, then we're going to graph them, and then we'll write the interval notation. Okay, so this first one, 4x plus 5 is greater than 8. Oops. So I'm going to solve this like a normal equation. And the only thing I have to remember with inequalities is if I divide by a negative, I have to flip the sign. Or if I multiply both sides by a negative, I have to flip the sign. But we tend to do division more than multiplying. It happens every once in a while, but we tend to do division. Okay, so let's see. That's going to be -5. So that's 4x is bigger than 3. So this is going to be x is bigger than 3/4. Okay, for the other one, 12x minus 1 less than or equal to 11. Okay, so for this one, adding the 1, 12x is less than or equal to 12 divided by 12. Okay, so that one came out nice. X is less than or equal to 1. Okay, so visually, if I kind of think of these two graphs, right? X is bigger than 3/4. Let's see, so here's 0. We'll just say this is 3/4. Bigger than 3/4 is going to look like this, right? Going this way. For x is less than or equal to 1. So 1 would be just a little bit over from 3/4. And it's got a bracket and it's shading the other direction. less than or equal to 1. Okay, so for this, since we're doing or, we're combining these two together. So the final answer then is going to be the whole number line. So the whole number line shaded, because they overlap each other. And if we're combining the two of them together, it ends up being the whole number line. And then in interval notation here, I'm going to do it in green, which is what I should have done last time. It's going to go from negative infinity to positive infinity. All right, let's try another one. So for this one, we're going to solve this first equation by adding 5 to both sides. It's going to give us 9. So x is less than 3. Over here, I'm going to subtract the 2, which will be a 4. And then I divide by -1. And because this is the first time I'm dividing by a negative, I'm actually going to flip the sign and it's going to become -4. Okay, so, oops, x is less than 3. Okay, so here's 3. Less than 3 would go parenthesis to the left. And then x is bigger than -4. Oh, wow, I should have done the number line a little better here. Here's 0. Here's -4. See, I should have had this one going like that. Bigger. All right. It's parenthesis, and this time going to the right because our number is bigger than 4. So we are looking at an and inequality, which means we're combining these two graphs and together into one graph. So as one graph, we're looking at, I'm sorry, not combining, and is what they have in common. So we're looking at what these two graphs have in common, and what they have in common are all the numbers from -4 to 3. So these are where the graphs are overlapping. So that's what they have in common. And so my final graph then, oops, is going to be 1, 2, 3, 4. There's -4. 1, 2, 3. There's +3. And there are parentheses shading in between them. And in interval notation, that would be from -4 with a parenthesis, comma 3 with a parenthesis. All right, let's try again. So this one, we're going to go ahead and -7, which gives us 0. That's fine. 0 doesn't freak me out. I love 0. It's the easiest number to work with. So when I divide 0 by anything, it stays 0. But because I'm dividing by a negative, I do need to flip the sign. So there we go. It's less than or equal to 0. Over here, adding 4 is going to give us x is bigger than 2. Okay, so there's my two things that I'm looking at. So 0 less than or equal to is going to be bracket going to the left. For the other one, it's going to be 2 would be right here. And it's a parenthesis and it's bigger than 2, so it's going to the right. We're doing and. Oops. So and is what they have in common, and they have nothing in common. The graphs don't have any sort of overlap. All right, so this is the case where we leave the graph empty, and the answer in interval notation is the empty set because there's nothing to shade. They have nothing in common. Come on, computer, keep up with my color changes. All right, let's try one more. So for this one, I'm going to add 5 to the 9, which will give me 14, divide by 4. Okay, so it doesn't go in evenly, but it does reduce to 7 halves. This one, subtract 3. We've got the magic 0 again. Dividing by -1 is going to flip the sign. All right, there we go. Okay, so 7 halves, that's about 3 1/2. Not about, that is 3 1/2. So here's 0. 1, 2, 3, 4. Okay, so 3.5 would be right in the middle. I didn't really need to do it like this, but it's fine. Bracket, and it's shading, let's see, less than. So it's going to be going to the left here because these are all the numbers that are smaller than 3.5. 0, and it's going to the left also. Bracket. All right. And we're looking at or. So or this time we're combining them together. And if I kind of put these graphs together, it's going to end up looking like the bigger graph. Even though there's a bracket at 0, I don't have to include that in the final answer because it's implied that 0 is included when I'm shading over it. So my final answer then, 1, 2, 3, 4, would be starting at 3.5 and shading to the left. So in interval notation, that would be negative infinity, comma, 7/2, or you could put 3.5 if you really want to, with a bracket. And that's how the final answer will look when we combine the two graphs together.